Hey everyone, it's Mark here from Offworld Empire, just checking in. Sam is still on Mars or Hawaii in the dome doing his high seas mission, and we've got some cool content coming along those lines soon, so watch this space. But I wanted to just quickly talk a bit about this new discovery that NASA announced. It was another huge NASA announcement, the classic thing that they always do, try and get everyone really excited about it, and it works, totally works. And they were announcing the discovery of 7 roughly Earth-sized planets in a system called the TRAPPIST-1 system. So TRAPPIST is actually a telescope in Chile. So this is a ground-based observation, and I think they discovered the system itself which has been called TRAPPIST-1 after the telescope. The system is a cool dwarf star, so it's a really tiny, really cool star, about 40 light years away. So it's pretty close in terms of the Milky Way, and they discovered I think 3 rocky planets there sometime last year, but now they've upped that number to 7. There's 7 rocky planets. All of them are roughly Earth-sized. So I think they just float around about 1 Earth mass in terms of their actual, size, and all of them are orbiting super close to the star. Actually, the furthest one out is still really much closer than Mercury is to our sun. So that's pretty crazy. Because the star itself is small, it's what they call the habitable zone, which is just the region where the temperatures are such that water could potentially be liquid on the surface. That region is much closer into the star than it would be for, say, like a star like the sun. So at least 3 of these planets seem to be within that habitable zone. So this is the big headline, essentially. There's 7 rocky planets, 7 orbiting this star, 3 of which are in the habitable zone. And this is obviously a massive deal. The news is going crazy. People talking about searching for life there, and this could be our nearest neighbors. Who knows? Maybe even intelligent life. People kind of run away with the headlines here. But there's a few things to consider with this discovery. So first of all, obviously, it's really cool that more and more systems, ground-based systems, telescopes like this, are starting to discover planets close by. Because obviously, the Kepler mission, which has been focused on a region of sky like about 300 light years away, is all to do with statistics. So what's the population of planets in the galaxy? How many planets are there out there? How many stars have planets? So it's been looking at this region of sky long way away, because it's much more efficient. You can focus on this tiny patch of sky without moving the telescope too much and actually capture quite a lot of stars, whereas to look close, you have to keep swinging around and checking out all close by stars. So it's really cool to see ground-based systems like this actually doing this with close stars. And as we discussed, a few months ago, the Breakthrough Starshot mission, which is this absolutely mad mission concept put forward by, or funded by, at least the development of it is funded by this Russian billionaire Yuri Milner, to try and send tiny little probes to another star system. Obviously, 40 light years is pushing it, because we're only going to be able to get up to about 20% the speed of light with their design. So 20% the speed of light, it will take a very long time to get 40 light years, so they'll obviously be looking closer. But it's still really cool that we're looking at close systems like this and starting to get some information, because once the next generation of telescopes are active, we can start training them on these close by systems that we already know have cool stuff going on. So things to bear in mind about TRAPPIST-1. So the star itself is pretty different to our stars, to the sun. If you were to look at the spectrum of light emitted by this star, there's going to be tons more X-rays and stuff being just absolutely hurled out of this star onto these planets. And some people even think that even with really powerful dynamos like magnetic fields like we have on the Earth, even with that, you still strip atmospheres too rapidly on with these kind of planets, with being this close to this kind of star. So that could potentially be bad news for life. On the other hand, these type of small stars are just last for ages. I don't actually know the numbers, but many times the lifetime of the universe currently. So there's a lot of time for stuff to happen on these planets. If, maybe in the subsurface where you're shielded from these X-rays, if the surface temperatures are such that liquid water could exist in near subsurface environments. You've got a long time. You've got billions of years, much longer than our solar system is going to be around for. And obviously we've seen what's happened here in a mere 4 billion years. This is what, we get to a point where I'm able to sit here and make videos about it. So, given tens or hundreds of billions of years and a system like TRAPPIST-1, that there could be some really cool biological innovations that get round some of the problems like the UV and the X-rays. But anyway, other stuff that's really weird about this system is that these planets, these 7 Earth-sized planets, that close to each other and that close to the star is weird. It's really bizarre, and it's going to be challenging a little bit about what we know about planetary formation. I mean, exoplanet discovery is generally this is the rule, really, not the exception. Pretty much, so many systems that we've discovered have overturned how we think planets form. I don't mean the fundamentals. I mean planets coalescing from a disk of distributed dust, and forming slightly larger and larger chunks that then come together and stick together and form planets. That holds. That model holds. But actually, how you go from that to a system like the Earth, where you have a system like our solar system, where you have large gas giants far out from the star and the rocky planets close in. That was assumed to be okay. They must all be like that. But the more and more stuff we discover, the more complexity is built into this idea. Two of the planets, their orbits are so close that I think they pass each other at 1.5 times the distance from the Earth to the Moon. It's like another planet. It's just sort of sailing by. You would see them in the sky, several times the size of the Moon, the Earth's moon. So imagine that, just walking down the street and you look up in the sky and there's 3 planets up there, all several times the size of the Moon. I mean, yeah, so the view from these planets would be amazing. And there's been people artist impressions and stuff that you can go and check out. People are trying to imagine what that would look like. So it's cool stuff, but the question of habitability is a bit of a tricky one. The word habitable is, I don't have a problem with the concept of talking about a temperature region from a star. That's actually a really useful thing to think about. But there's a lot of factors that come together to make something habitable. We don't even really understand what all those factors are and how unique the Earth is in that sense. I mean, it certainly seems unique in our solar system. Venus and Mars should be fairly similar, but they've obviously gone in very, very different directions. So these planets could have absolutely horrendously massive atmospheres like Venus and be hot and high pressure, far too hot for any kind of organic chemistry to be going on. Or they could be barren. Their atmospheres could have been stripped away by the X-rays and the UV from the star, and be freezing cold, and all water being locked as ice or vapor that's then lost to space. So both of those scenarios could be the case, and there's plenty of other things that go into making, or we think might go into making, a planet habitable, such as things like plate tectonics and the existence of a moon to stabilize obliquity. I mean, all of these questions are just things that we just cannot get at. We don't know enough about why the Earth is the way that it is, and we also don't know enough about these planets. I mean, all we really have from these planets are their size and an inferred density, which tells you that they're rocky, and the time it takes for them to go around the star and that kind of thing. I mean, we know very, very little. They do have, I think they have a tiny bit of information from reflected light from a couple of these planets, which means they've managed to rule out, I think, hydrogen and helium being major components of the atmospheres for some of these planets. I mean, that doesn't sound like much, but it basically tells you that they're not Jupiter-style gas planets, because they're predominantly made of helium and hydrogen. So I think they've managed to rule that out. But obviously, one of the next steps is to try and actually get atmospheric compositions for these planets. If they have atmospheres, what are the atmospheres made of? That is going to be really exciting, because maybe we'll see water vapor. Maybe we'll see strange. You'd look for something like a disequilibrium. Oxygen, for example, pretty reactive, should get sucked into minerals and rocks and react with stuff and not be present in the atmosphere unless it's being continuously produced. So something like oxygen could be like a really, really cool signature that there's some process happening on that planet which is hard to explain without biology. So that'd be really cool. And we've obviously got missions coming up that are going to be looking at the atmospheres of planets like these. James Webb Space Telescope, obviously, is one of its main things it's going to be doing. Is following up some of the most promising leads from Kepler and from other ground-based observatories, checking out some of these planets, looking at their atmospheres. That's going to be really cool. We've obviously got a whole load of ground-based telescopes that are going to be brought into action. So lots and lots of cool stuff coming up on that front. And I always like, just the more information we have about the population of planets in our galaxy is just always good information. I mean, the more we can learn about that, the more we find out about how rare we are or how common a system like ours is in the galaxy. So all very cool stuff. Definitely going to be watching that space. So yeah, that's going to be it for this sort of brief video, but definitely keep your eyes peeled, because in the next few days probably we're going to be having some content from High Seas 5 from inside the habitat for the Mars mission simulation that Sam's involved in. So that's going to be really cool. Can't wait to see some of that. So if you want to find out when that comes out, guys, make sure you subscribe and like the videos, share the videos, spread the word, and yeah, keep your eyes peeled for some more content. Cheers.